Sodium ions.
Potassium ions. Calcium ions. Negatively charged proteins and ions. Sodium channels. Potassium channels. Calcium channels. Sodium potassium pump. Myelin sheaths.
Dendrites.
Cell body. Zach the talking axon. End bulb. Synaptic vesicles and neurotransmitters. Ooh. Positive and negative charges.
When a neuron is at rest, it has a net positive charge outside of the cell and a negative charge inside of the cell. In the cell body, which is also negative, it has phosphate ions, sulfate ions, and chloride ions, along with negatively charged proteins. The sodium-potassium pump pushes out 3 sodiums for every 2 potassiums in. This process repeats, resulting in a net positive charge on the outside of the cell. The process starts when a neuron receives an impulse. When the stimulus reaches the neuron membrane on the dendrite, sodium channels open, and sodium rushes into the cell, making it positive on the inside. This process is known as depolarization.
Nerve impulse moves down into the cell body. It triggers depolarization, which opens the sodium channels, and sodium continues to rush in.
The nerve impulse moves from the cell body to the axon, continuing to open sodium channels. Due to the myelin sheaths covering sodium channels, only the uncovered channels open to allow sodium to rush in. These spaces in between myelin sheaths are called nodes of Rambier.
The process of action potential continues opening sodium channels all the way down to the end bulb. As sodium channels open and sodium rushes in during depolarization, potassium channels immediately open, starting repolarization, and sodium-potassium pumps start, restoring the membrane potential across the membrane of the axon. The nerve impulse reaches the end of the axon. It stimulates calcium channels to open, and calcium rushes into the end bulb. When calcium rushes into the end bulb, it causes the synaptic vesicle to merge with the cell wall and release neurotransmitter outside the cell to the next dendrite.
The nerve impulse continues through the end bulb, and the neurotransmitters move into the next neuron, restarting the same process all over again.